finally, in this set of slides, we're going to look at how to change augmented coefficient matrices into row echelon form, or even better, reduced row echelon form, using something called Gaussian elimination. This process is detailed because it can take quite a few steps. So I'm going to show you one full example before these slides are done, and then I will refer you out to look at examples in the text, and heck, go out there and find lots of videos online of other people doing other examples, because they're already there. I don't need to reinvent the wheel here, so I'll get you through one, and either it'll click right away and you'll be like, okay, I've got this, or you can go out there and find other resources, or come find me and I can help you work on more. So the roots to this process are going to be back in high school when you solved systems of linear equations by hand, and you did something called elimination. So if you think back to when you had to solve a system like this, one of the strategies you might have taken is to look at that coefficient of 2y in the first equation, and then look at that second equation with a minus sign just sitting there, and thinking, oh man, if that was a negative 2y in that second equation, if I could add those two things together, the y's would disappear, and that would be so awesome. Well, we make that happen, right? We multiply the second equation by 2 to make that a negative 2y. We add those two equations together, and then we've produced a new equation that goes in place of equation 2. And that eliminates the term y in the second equation. So, elimination, Gaussian elimination. Now, having done that, this is the result. The first equation is the same. The new equation in the second spot is now 5x equals negative 10. And right here you can see we are ready to discover the solution, right? X equals negative 2 from that second equation. Plug it back into the first equation to discover y equals 3. Okay? Or we could continue with the elimination process. For example, we could multiply the first row by negative 5. Then we have a negative 5x in the top equation, of positive 5x in the bottom equation. Add those two new equations together and replace the first row, and we would end up with this. Now, this is a little clunky and disorganized, so let's flip the order of the equations, divide by a couple of nice constants, and end up with x equals negative 2 and y equals 3. And now the solution to our system is right there in front of our face. And now think back to the augmented coefficient matrix of this system, x equals negative 2, y equals 3. It would be a matrix in reduced row echelon form. And so what we're going to do is we're going to build augmented coefficient matrices. We're going to do exactly these kinds of row operations to the rows in those matrices to take the original messy augmented coefficient matrix with all the coefficients in it, eliminate them progressively until we're left with row echelon or reduced row echelon form. Okay, so the summary of the row operations you are allowed to use, these are called elementary row operations. Just like with the equations themselves, you are allowed to multiply any row by a constant. Now, don't multiply by 0. That would spoil the whole thing. You could, but it doesn't help. Multiply a row by a constant, cleverly chosen, so that you can then add two rows together to make something disappear, and you're going to replace a row with that result, and you're also allowed to change the ordering of the rows if it's convenient. This process is called Gaussian elimination. Well, it's called Gaussian elimination in general, and if you happen to make it all the way to reduced row echelon form, then you have done Gauss-Jordan elimination. So generally speaking, here's the process. This is a worst case scenario for a coefficient matrix. This would come from the system ax plus by plus c equals capital A, ex plus fy plus gz equals capital B, and so on. Presuming all these coefficients are non-zero to start with, we're going to start taking them out and turning them into zeros. And here's the overall strategy. Adapt when you find clever ways to adapt, but otherwise just go with it. So we're going to start with that top left-hand entry. We're going to use that as the arrow to shoot out the entries below it, thinking about, what can we multiply each row by so that when we add things together, something's going to vanish. But the idea is use the upper left-hand entry, currently called A, to take out the two digits below and turn them into zeros using our elementary row operations. Okay? Now, if you can make that entry a 1 by division of the row by a nice constant, go ahead, but if you see yourself introducing too many fractions, you might want to hold off on that because those fractions will then propagate throughout the process, and it can get gross. So if you can make a 1 nicely, go ahead, otherwise don't worry about it. Once the first column is taken care of, we'll go to the second column. We'll now attach ourselves to the middle entry. In this case, the red F. We're going to use that digit to take out the ones above it and below it to produce this. And remember, the numbers that are in the spots that are lettered, the A, the C, the F, G, K, these are all changing all the way along. Like the G sitting here in this new matrix isn't going to be the G that was there on the first page necessarily, and the A is not going to be the same necessarily. So things are changing. I'm just trying to indicate where are the zeros and where are not any zeros. Once we've taken care of that second column, we move to the third column, fix on the third digit in that third column, and take out the 2 above it with row operations. And you can see what we're building to here. We are really, really close to reduced row echelon form. It's just that those digits A, F, and K may not be 1s. At this point, then, you just go ahead and hit those rows with a multiplication or a division to turn them into 1s. And again, you're going to be changing the values of capital A, capital B, and capital C along the way. But now the solution to your system is sitting right in front of your face. Okay, so again, think about the elementary row operations. Multiply rows by constants, add rows together. So pick your constants cleverly to make things get eliminated. Replace a row with something you just created. And if you need to, interchange rows. Your job here is to create zeros in nice spots, so make sure that you're not doing a row operation that will mess up a zero that you've already created. If you're about to do that, think of a different move. If you can produce 1s on the diagonal, do it, but only if you don't introduce messy fractions. If you're going to introduce messy fractions, hold off till the end. You can always fix the 1s later on. As you're going through this process, be alert to the visual clues that, uh-oh, we've just found out there's no solutions, or uh-oh, we've just discovered there's infinitely many solutions. So here's a full-blown example. So we're going to start with this system of equations, 3 unknowns. We're going to build the augmented coefficient matrix, and now we're going to start our Gaussian elimination. We're going to start in the left-hand column, and we're going to pick the red 1. That one we don't want to change permanently. We can temporarily multiply it by something to help eliminate things, but ultimately that first row will stay the same. We're going to pick row operations such that the 2 and the 3 below the red 1 will get eliminated. So for example, if we were to multiply the first row by 2 and then subtract row 2 from row 1, that would create a 0 in that spot. And so what we'll do is that very operation. We will do 2 row 1 minus row 2, put that result into row 2. So digit by digit, 2 times 1, 2 times the red 1, then minus 2 gives us the new 0 for row 2. Moving over, 2 times 1 minus 4 gives us negative 2. 2 times 2 minus negative 3 gives us 7. And 2 times 9 minus 1 gives us 17. So we've made a new row 2, but a new row 2 that has a 0 where we want it. Similarly, we can do 3 times row 1, the old row 1, minus row 3 to put a 0 where we want it, and then we let that change propagate down the rest of row 3 as well. So take a second, pause this if you need to, and make sure you agree with those new digits, negative 3, 11, and 27, under that row operation. Having done that row operation, we're going to move to the second column. Now we'll pick on the negative 2. That's the one we kind of want to put a thumbtack in, and we're going to use that to take out the digits above and below. So, golly, if that number 1 in the top row right above the red negative 2 was a 2, that would be great, because then we could just add those 2 rows together and produce a 0 that could go back in that spot. So let's do 2 times row 1 plus row 2 and replace the result in row 1. And then also, we need to combine the second and third rows. Again, we need to use the negative 2 as the arrow that's going to shoot out the negative 3. Now this one you have to think a little bit more, because we can't just multiply one of those rows by a good number. We're going to have to go find a common multiple sort of thing between the negative 2 and the 3. So we're going to take the second row, multiply it by negative 3. That will give us a 6 in place of the red negative 2. And 2 times row 3 will give us a negative 6 sitting right under it, so that when we add those 2 together, we will produce a 0. Now I think here you definitely want to pause this and do that row operation, step by step to see it happen. take that second row, multiply it by -3. So multiply all the numbers by -3. Take the third row, multiply all the numbers by 2, and then go down the rows and add up all the independent results to produce the new row 3. Make sure you see how that works. Okay, we're almost there. Now we're going to move over to the third column. We're going to fix that lower right-hand 1 that's now in red. We're going to put a thumbtack in that and use that as the arrow to shoot out the 7 and the 11. So to take out the 11 in the top row, let's make the red 1 into a -11. So multiply row 3 by -11, add row 1 and row 3 together, put the result back into row 1. And then similarly, pick a clever set of row operations to fix up row 2. Pause this if you need to, carry these things out, and make sure you see how it evolves. This final result is so close to reduced row echelon form, and so if we divide row 1 by 2, row 2 by -2, leave row 3 alone, we now have fully reduced row echelon form. The solution to our system of equations is right there in front of our face. The solution is x equals 1, y equals 2, z equals 3. And we're done. Ta-da! Okay, so again, keep in mind during this process to be on the alert for strange things happening. So here's a matrix, a coefficient matrix, and let's say we're in the process of doing this Gaussian elimination and we're at this point right here. We want to use the red 1 to take out the blue 1, and so maybe we would want to just do row 2 minus row 3 or vice versa. Well, if we do that, look what happens. If we replace row 3 with the result of row 2 minus row 3, we end up with 0, 0, 0, -3. So we did what we wanted to, which was to change the blue 1 into a 0. That was fine. But we produced something weird. And if you think back to the last slides, this is now our visual clue that we've just discovered that this system has no solutions. Right? Because that last row is now telling us that the information in this system says that 0x plus 0y plus 0z equals -3. That will never be true for any values of x, y, and z, and so this system doesn't have solutions at all. And that's good because that means you get to stop. You don't have to do elimination any farther because there's no solutions to find. Okay, so as you can see, this is kind of a detailed process. The only way to pick it up is to try it several times. So we'll do another example in class. There's examples in your textbook in 3 different sections. If you have your textbook from Math 270, there's more examples in section 3.2. There's videos all over the place of other people doing this online, so you can go out and find some. Here's the URL for one of them. It's by a guy named Patrick JMT. That's pretty clear to watch, so that might be a good one to start with. But there's plenty of resources out there if you need to see more examples.